Hello everyone, this is Professor Chan for Math 1245 speaking. Today we're going to be going over the last part for section 3.1, and that is dealing with optimization for quadratics. So we did vertex for quadratics, and we're going to talk about what it looks like in a different form. So in this situation, sometimes we're going to give you word problems, and you have to kind of determine how to solve it for the following here. Okay. So it says, suppose that the manufacturer of a gas clothes dryer has found out that when in unit price is P dollars, the revenue in R dollars is the following function. What unit price should be charged maximum revenue? What is the maximum revenue? Okay. So a big keyword is notice they say maximum. So when they're trying to find maximum or minimum, right, they're actually talking about vertex. Okay. So do be mindful about this. Now they gave us two questions, all right, and we have to solve both of these questions. So it says what unit price should be charged to maximize revenue and what is the maximum revenue. Okay. So let's understand what's happening here. Okay. So we want to, because we're actually graphing, we want to actually understand what my x is and what my y represents. Now, if I look at this function here, I notice my x is actually p, right? Because I have numbers next to p and I have p squared, right? And you think about your quadratic, you have like x squared plus x. Okay, so my unit price, p, is really my x. And then my revenue is going to be my y. Okay, so I just want to make sure I'm kind of listing this down, writing which one's my x, which one's my y, so I can understand what's happening. So the first part of the question, they say the following, right? It says, what is my unit price P? So I'm actually trying to find this part here. I'm actually trying to find the x coordinate of my vertex. Okay. Now, how do we find the x coordinate of my vertex? It's actually pretty straightforward, right? All I have to do is to use my formula, which is x is equal to negative b over 2a. So this is going to be negative 1900 all over 2 times negative 0.5. I'm just doing that because it's a lot easier to write that than 1/2. So I have negative 1900 negative 2 times negative 1/2 is negative 1. So this will be equal to 1900. Okay. Now I'm going to say $1,900 because I'm being asked for a specific price. So my vertex, so the first part is going to be $1,900 here. And that's it. Now the second part, they're saying maximum revenue. So you're actually being asked to find the y value for the following here. Okay, so we're going to do the following here. I'm going to plug in 1900. I have negative 1/2 times 1900 square plus 1900 times 1900 for the following. And let's enter this into our calculator. Let's see, 1900 square, 303.6 million. So negative 1, 2, 1/2, 3, 6, 1. And there are 4 zeros. And this is also 4 zeros. Okay. Multiply that by 1/2. negative 1/2. And I have negative 1805 and 3 zeros. Okay, so that is in dollars, because that's what it says, revenue in dollars, and that's my final answer here. Now, you can also check by using your graphing calculator. So let's talk about this right here. Okay. So, sorry about that. I'm going to just graph using my graphing calculator, right? So it was negative 0.5 x squared plus 1900x okay. Now I'm going to graph this. Now the thing is, obviously if I graph this here, I can clearly see that it's not going to fit on my screen. So I have to go to my window, and I'm going to have to manipulate this around. Okay, so let's think about this here. So since if I look at this, since my vertex is at 1900 for x, I'm probably going to double my x max. It's probably going to be like 3800, right? Because because 1900 is technically the halfway point. And then my y max, let's take a look at this here. So 180500, let's do 2 million. For following, and we can graph this. Okay. Yeah, so essentially what I'm doing is my y max is a little bit larger than my y maximum. Okay. And then my x max is double essentially what my x coordinate is. And this will assume I did everything correct. Okay. So how do I find my maximum? Okay. I'm going to do the following. I'm going to hit second trace, and I'm going to select option 4, which is maximum. Now, obviously, if it's a minimum, you'll select option 3, and you'll essentially do the same thing of what I'm going to do in a bit. So I'm going to hit enter. So you're going to see this little cursor here, and it says left bound. So all we're going to do is we're going to move our cursor, right? I'm going to hit the left arrow till I'm to the left of my maximum, and I'm going to hit enter. Right bound, I'm going to move my cursor to the right of my maximum and hit enter. And then in order to guess, I'm going to hit enter one more time. And notice I get my coordinate, right? 1900, 1,805,000. And that's what we have, okay? Now, obviously, you need to make sure you know how to do the math and you need to show your work, but this is a good way to kind of check to see if you did everything correct. Okay, so let me do this one more time. Second trace, go to option 4 or option 3 if you happen to have a minimum, but then you'll scroll your cursor to the left, hit enter, then your cursor to the right, hit enter, and hit enter one more time. Okay, so we're going to start another example. Okay, let's do this one here. It's number 3. Marginal cost of manufacturing X portable CD players is given by the following. How many portable CD players should be manufactured to minimize marginal cost? So it's the minimum marginal cost, right? So minimize is also vertex. I do want to figure out which one's my X and which one's my Y. So what does my X represent? My X represents CD players. Okay. And then my C of X, right, represents costs, which is my Y, right? Okay. So let's do, so in order to find my vertex, right, I'm going to first use my x is equal negative b over 2a. So this is minus negative 9 over 2 times 0.05. This is 9 over 0.1. And if I divide that, I have x is equal to 90, 90 CD players. Okay. So then, the second part, how to find minimal marginal costs, again, pretty straightforward as what we've been doing before. Right, I'm going to plug 90 into my function. Okay, so that is 0.05. 90 squared is 8100. Sorry, let me redo that again. And then this is 810. Let me just double check. Yep. Okay. Plus 435. 8100 times 0.05 is 405 minus 810 plus 435. It'll be 30. So that is my minimal cost. That is my final answer. Okay. Now, let me show you if you want to double check. So I'm going to graph this. I think it was 0.05x squared minus 9x plus 435. Let me just double check. Yes. Okay. So you're going to go to your window. Now my x minimum was, sorry, my x during the vertex was 90. So I'm going to double it. I'm going to think it's 180. Okay. Now let me explain why I'm doubling it, because remember from 0 to 90, that's when it goes all the way up. Or sorry, in our case, drops all the way down, and then from 90 to 180 is going to rebound. Okay. And then y min, now we know we want our 30. Let me just go up to, like, let's go up to 100 and see what happens here. Okay. And that's a good enough parabola for the following. Okay. So hit second trace, go to minimum this time. And again, they're going to ask us left bound. So we're going to scooch over to the left, hit enter. They're going to go to right bound. We're going to move our cursor to the right bound. Sorry about that. Hit enter. And then when I say guess, just hit enter one more time. And we have it here. Okay. And this is actually a good situation to have. I want to show this to you. Sometimes your calculator can be a tiny bit off. So notice it's 90.000006. Sometimes there's a little bit of a glitch like this that happens. You just have to realize they're just saying 90. Okay. So don't worry about that. Now, if you want to go back to your regular 10 by 10 window, remember this, we went over in the calculator section, hit zoom and then go to 6. And you go back to your regular 10 by 10 window. Okay. And then if you want to get out of the screen, you can just hit the clear button. Okay. Or you can just turn off your calculator and then turn it back on. Okay. Okay. So we're going to talk about our very last type of problem. The last type of problem can be a little bit difficult because this time they do not actually give you a quadratic function. You have to create it yourself, okay? So I'm going to show you this one here. Please practice this one, okay? You will run into situations like this here. And if you have questions, do feel free to send me an email. So it says the following. It says you have 600 feet of fencing to enclose a rectangular plot that borders on a river. If you do not fence the side along the river, find the length and width of the plot that will maximize the area. Okay, let's do the first part first. Okay, because I know there's two questions. I'm not going to answer the second question yet. So let's draw the situation, right? So I have it borders on a river, right? And I have some plot of land that I want to encase it, and then there is a river like the following. Okay, so let's understand, right? So I have my two lengths or two widths, depending on the picture you draw. This is it's kind of irrelevant, but don't worry too much about this here. Okay, so I have two lengths and a width, and I have 600 feet of fencing. Now let's talk about this. So the perimeter is 600. Okay, and in my case, it's 600 is equal to W plus 2L. Okay, because if you think about it, if I add up all those sides, it'll be 600. Now, you may run into problems, so listen carefully. You may run into problems where you're just being asked to create a rectangular box without like bordering on a wall or a river. So in that case, it'll be 2W plus 2L, right? Because that's the perimeter of an entire rectangle. But I'm just doing W plus 2L because one of my sides, right, is blocked by the river. Okay. Now, I also know that I'm trying to do something to maximize the area. So I'm going to use the area of a rectangle. Whoops, sorry. So what is area of a rectangle? It is area equals length times width, okay? And we're going to make a function out of this area. Now, here's a situation at hand. We're actually kind of stuck because if you notice the following, we have 3 letters, which is not good, right? When we do a function, we only have 2. We have y and an x. We have 3, and that's problematic. So this is what I'm going to do. I have another formula, which is W plus 2L is equal to 600. So this is what is going to happen. I know W plus 2L is equal to 600. So what I'm going to do is I'm going to subtract 2L on both sides. Okay, so why am I doing this? Because I want W by itself. You could get L by itself. I'm just doing it because it's a little bit easier for the following here. And then, because W is by itself, what I'm going to do is I'm actually going to plug this into here. Why am I doing this? Is because if I replace it, what's going to happen is now I'm just going to have a bunch of L's as opposed to L and W, right? Because W gets replaced with 600 minus 2L. So it'll be L times 600 minus 2L. So I have 600L minus 2L squared. Let me rewrite it. For the following right here. So this is my quadratic function, which is pretty nice, okay? And now that we know our quadratic function, then we can answer our 2 questions. So my L, my length, is my x, right? And then my area is my y. Okay? So it says, what is find the length and width of the plot that will maximize the area? Sorry, I'll call this A, and then I'll call the second part B. So part A what I'm going to do is I'm going to find the vertex, which is x is equal to negative b over 2a. And if I look at my formula, this is going to be negative 600 divided by negative 2 times 2. Negative 600 over negative 4. That will equal to 150. So my length is going to be 150 feet. Okay? Okay. I'm going to plug 150 in. Now, how do I find my width? I'm going to plug my 150 into my perimeter equation. I'm going to plug it into here. So W is equal to 600 minus 2 times 150. Okay, and this equals to 300. Okay, now, obviously, we know our width is longer than our length, so you can flip them around. So you can say this is technically your W, and this one's technically your L, okay? The most important thing is just make sure that you have both of them, okay? And then use your common sense. Obviously, whichever one's longer, that's the one you'll use for length. And whichever one's short, that's going to be your W. And you will run into situations where they'll be the same for the following here. So that is part A. Now, how do I find my area? There's actually two ways I can go about it. I can just do the following here, where, right, area is length times width, and it's 150 times 300. And I get 45,000 square feet. Right, and that'll be my final answer here. Now, I can also do, if you look at the calculator here that I did really quickly, is I can also plug 150 into my equation, right? F of 150, sorry, A of 150, my bad, is equal to negative 2 times 150 square plus 600 times 150, which is what we did before. And I'll also get 45,000 square feet. Okay, so actually either of these would work. Whichever one you're more comfortable with, go for that. Okay, you will, so I'm only showing you one example of this, but you may see some of these in your homework. So please practice this. This is definitely one of the trickier ones because you have to make sure you find your function for the following. But once you find your function, everything else should be pretty straightforward from what we're doing. But do practice this. The way you want to think about this is you have a function with three variables, and you want to turn into 2 by using substitution in. If you have questions on this problem in particular, feel free to email me or put it on the discussion board. But other than that, we're finally done with section 3.1, and we're gonna start with 3.2 the next day. Okay, talk to you later.